Sometimes it's easier to look at things the other way. When are you not going to derive? Well, there is one case that is quite simple. It's when you need more than one object of the ancestor type. Let's think about it. In the case where you were in the CL print invoice class, clearly you only need one CL print to do the thing, because CL print contains all the method to manage the basic stuff. But let's say that you create a class that is going to do all your high level invoicing management, everything. And in that class you're going to need several invoices at the same time. So you cannot inherit from the CL invoice class. If you inherit from the CL invoice class, you have one invoice there. In the high level management class, you're going to need an array of objects of the CL invoice class. So in a case like that, you are not going to derive your CL invoice class to do your high level invoicing management. You're going to do your high level invoicing management in a separate class on the side, and this one will have several objects of the CL invoice class. So that case is generally quite simple to understand. I would also suggest that you do not derive, you do not create another class when you have only one line of code changing. That's the kind of thing that I've seen done by people I call the ayatollahs of object-oriented programming. If there's one line changing, it's not the same class. Well, yeah, perhaps in a school, perhaps in university they tell you that, but in the real world you need to be able to find what you're doing and where. So again, keep it simple. Also, there's a very good reason not to derive a class if you know for a fact that the original class will never be reused anywhere else. If it's a one-time thing, that's something clearly specific that has no other use anywhere, why would it be in a separate class? Let's take an example. My CLDB class is there to manage access to a database inside a WinDev or WebDev program. I use it indifferently in my web project and in my WinDev project. Clearly, I need to be able to manage several types of database. It can be Hyperfile Classic, it can be Hyperfile Client Server, it can be MySQL, and so on and so forth. So, do I create several classes, one per type of database, or only one? What is really needed to manage different types of database? Well, basically you're going to do either a hsens rep or a hsens connection. Sorry, it's hchange dir in English. So, because I'm using hsens rep in one side and hchange connection in the other, I'm going to do different classes. Derive the class, replace them. There's no clear hierarchy here. MySQL is not higher than Hyperfile, or so it's not a question of one being a higher level than the other and doing more things. Of course, I could create basically an empty CLDB, and each of the other ones, CLDB HF, CLDB HF Classic, CLDB MS SQL, would derive from it. But what is the gain? If I have just one empty that CLDB class before and nothing in it, what exactly am I doing? Just sharing some variable? What's the point? So again, when are you going to create a new class? When are you going to add method to a class? It's really a question of common sense. It's a question of Are you going to gain something by doing it? If the answer is no, then why bother? Now, if you end up by doing that with several hundred functions instead one class, maybe it's time to have a closer look and see if you couldn't organize things a little better. If only to gain that you're able to find your method more easily when you're looking for them. So that's one gain too. It's the gain for the developer, and after all, we're here to gain time and code better. Now let's have a look at another aspect of object-oriented programming, and this aspect is really three keywords: private, protected, and public. This is really the black box secret. We talked earlier about the fact that you can create code that is available only from inside the class, and you can create variables that are available only from inside the class. Well, this is how you do it. When you declare a variable, you can say that this variable is private, protected, or public, and when you create a procedure, you can the same way say that this procedure is private, protected, or public. So it's available on both members, which is the object name for variables, and methods, which is the object name for procedures. So one problem that I see personally, and perhaps nobody will agree with me, but it's that by default, when you're creating a class in W language, everything is public. The variable are public, the procedure are public, everything is therefore accessible from the outside of an object. And that is the exact contrary of what an object should be. An object should be a black box as much as possible in order to minimize the possibility that some external code is going to mess up your object, your behavior. So I would really prefer that everything would be private by default and that you would have to specifically declare things protected or public, but that's the contrary. By default, when you don't say anything, your variable are public and your method are public. My opinion, really, members should always be private. You don't want the code in some window far away in your program to do a change inside an object. You want it to call a method from this object and ask the method to do something. Now, in some cases, members should be protected if they are really needed in a derived class. It happens quite often. Of course, you could just have a method giving the information that you need or setting the information inside your class and passing that to the derived class. That's generally a better way to do it, but from time to time accessing directly the variable is simple enough, and the second class is close enough that you don't need that level of separation. But it's possible to protect all your members and have just some methods available as protected for communication with a higher level of a class. Most of the time, on the other hand, methods are public. If you create something, a function that works on an object, you will see that most of the time it's something that you need from the outside world. It's not always true. You can have only one or two access points from the outside world and everything else being private or protected. But you start with public methods and you protect the one that could create problem if called from the outside. Remember that somebody who's using your class does not know how things are organized inside, so they should access only really what you want them to access the way you want them. So you put your method at private when they are really nobody's business, and you put them as protected when they are needed in a derived class. And when they are needed from the outside world, you say that they are public and you can access them. Now we are reaching a point that is extremely important, and I would like you to really focus on what we're saying here. This is the notion of global, and it's something that is extremely powerful with object-oriented programming. The meaning of the keyword global in a class is very specific and is very different than in regular programming. It allows to access function of a class and members of a class without any objects. It means that you can access them before any objects are created and after all objects were deleted. To do that, the syntax itself is different. In a normal method, it would be object name colon method, which means that basically you're calling a function that is working on one object. And in a global method, you would say class name colon method, and that's why it's very important to make the difference between an object and a class. You're working on an object or you're working on the whole class. And a lot of people are talking about objects as classes, and that's a very bad idea, because suddenly this notion of global is even more difficult to comprehend. So when you're working on the whole shebang, it's class name .NOT method, and it's a global method. Of course, it is an either-or proposition. It's when you're coding, when you're writing your code, that you're saying, okay, this method is global, this member is global. You define it as that, and it's going to be global all the time. You cannot, when you call it, decide that this time it's not going to be global. It's something that you define when you are coding. So of course, members that you declare as global are going to be different. You're going to use the keyword global, and then suddenly this variable is going to be usable anywhere by anything with the syntax class name colon variable name. This means what? It means that the first line of your project could be my class name colon my variable equal something, before you create an object, before you define anything, which means that you can use it to store global information, and we're going to go into that in the next slide. So it's usable anywhere by anything, accessible by anything anywhere, modifiable by anything anywhere. It's not protected at all anymore. It's something that has become open to the whole world. Now, global methods cannot use directly normal members. There is no object. In a global method, you are not in any specific object. So you don't have this option of this notion of I'm inside my own object, so I have my own variable. Not at all. When you're in a global method, you can of course create an object of a different class or the same class and work on it, but you cannot access your own members because you don't have a own. You just work on global members, and that's all you can do. So this notion of global is well and good, but what is it good for? Why is it so important? Let's see, what can we do with these global methods and these global variables? Well, you can manage general settings. By example, in the CL log example, you have both global and not global methods. And in order to know how the different methods are supposed to work, you have some general settings that are stored in global global members. You can use this notion of global to manage the objects. By example, you can do a central repository. You have to understand that when you start creating a dynamic object, it's very easy to lose track. It's very easy to say, okay, I'm in a loop, I'm doing this, I'm doing that, I'm creating object for this, that, and the other, and I'm not sure what objects are created at any given time. So to manage that, the standard solution is to create a dynamic array of objects, and you store your object when you create them inside the array. This way you just have to go through your array to know what your objects are and what they're doing, and so on and so forth. Well, there are two ways to do that. You can do that in a separate class. So you have your class of records, by example, and then you have a class that is manage record. Absolutely possible. Which means, of course, that when you're using that in another project, you now need to move two different classes. The other way of doing that is to use the global methods and the global variables. Then you have some function inside your class that are here to manage all the objects of your class. A global management system for your own objects. And everything is in your class, and you can do that. So in this central repository, you have access to only what you store them. So it means that when you create an object, inside the object, in the creation of the object, you can say, okay, I'm going to record myself as being a new object of this class, and I'm going to put that in my global array of objects and say, okay, I'm here. And when you delete an object in the code inside the object that is doing the deletion, you're going to say, okay, well, I'm clearly being deleted, so I'm going to remove myself from the global array of objects. And then you will have function inside your class, global function, that are here to calculate totals on all your objects, statistics on all your objects. Do some garbage management, because, well, at some point you need to know what is still running when you close your program, when you call that function, and why do you still have 200 objects of this type in memory. And first you need to know that you do still have 200 objects in memory, and that is a very good way of doing that. Of course, that's garbage management, that also debug. You need to know that there are things that you are not deleting correctly at the right place. And you can organize things with that very easily. By example, I was talking earlier about the fact that you want to sort object and all that. Well, you can do that inside each object that is talking to the other, or you can do that inside the big global array of objects that you have and that you manage this way. One example that we have today, we have in fact two examples available in my project. One is the cllog general utility. Our cllog is there to trace and log information, so that you can use that for debug and all this kind of thing. The trace function is declared as global in order to allow to use it at any point in the program without having to create an object first. So to use it, you're going to do cllog : trace and trace the value that you want. You also have several functions: setMod, setLogOff, setLogOn. They are global because they are there to set value of options that are going to be used by all objects. When you create an object, it's going to look at these global settings and behave depending of what these global settings are. And then, if you create an object, a static object, anywhere in your code, The static object is going to have a constructor that is going to be fired when you create the object, and it's going to have a destructor that is going to be fired automatically when the object is deleted. So when you create a static object inside your window, it is going to be deleted automatically when the window closed. And that will allow both the constructor and the destructor to log information inside your log file or in your trace on the screen with only one line of code. That's extremely powerful stuff. What you do, you put one line of code saying, okay, my trace is CL trace, and eventually you type something in that, and that's it. When the window is open, there's a trace written in your log file, and when the window is closed, automatically there is a trace window in your log file also. So that allows you to automatically know when things are created, deleted, and all that. And that, at that point, is not a global function at all. It is creating an object. And this is an example on how you have both the power of the object and the power of the global functions inside one class. Another example is going to be in the CL form class, where we are going to manage the form, the different records of a file, and where we will have global functions and global members that are going to be here to manage the different objects of the class. We're going to create several of them, and they're going to be manageable, and we're going to have a list, and we're going to know what's what at any time. And you're going to have examples of that. UI or not? That seems like a very strange question. But when you start coding with classes and you're working in a program that is not pure mathematics but that has a UI, you're going to start doing things in your classes with the UI. That's something that is going to happen, no question about it. And it's better to start thinking about it now. You have to decide at the beginning, is your UI calling your class? So inside your window you are calling element of your class, or is your class calling your UI? And that, in that case, you have members of your class that are opening windows, closing windows, and so on and so forth. So either you're going to have your window that is open, and inside the code of your window you're going to say, okay, I'm declaring an object that is going to manage my data or this or that inside my window, or you're going to have code that is opening windows from inside your class. But you should never do both in the same class. If you do both in the same class, you're going to end up in a huge mess. So what should you do? Well, both are possible. Personally, I prefer to have my classes completely independent from the UI. Why? Because this way I can use my class from the web or from WinDev or from anywhere where I need to, and the UI, the part UI itself, is managed at the UI level. But you can do both, and I've seen both done. Please, 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 never do both in the same class. It's going to be a mess. I personally prefer to have all the UI outside of the class, but that is still acceptable if you have your UI called from inside your class. Just do it consistently. Let's have a look at what is needed when you're going to design some code as object-oriented programming. There are some differences with your regular work, and you have to think about them before you start coding, of course, in order to have something that is really using the advantages of object. So first, do you remember the black box concept? The black box, the object of your class, is going to need some values. So there are some values that are going to go in the black box. There are some values that you're going to want to get out of your black box, the results. And there is some action that is going to be done inside the black box, completely hidden from the outside world. So there will be, because it's a black box, no direct link with the UI, with any global variable or global procedure. The black box just doesn't know them. Okay, so you should never use in a class anything that has been declared outside of the class. You should not use global variable, global procedure, anything that is directly in the UI. If you need to do something in the UI, let's say that for whatever reason in your class you need to be able to put a value inside a field, inside a window. Well, you cannot directly name the window and the field in your code. That's not possible. What you can do is pass as parameter in advance to the class the name of the window, the name of the field, and when you need to put a value in it, you use indirections inside your class to set the value in it. And you put that in an exception treatment, because if for some reason the field does not exist at the time of the execution, the window has not been opened, you don't know anything about that, you are in a black box. So you need to make sure that when you do something in the UI, well, you are testing for errors, because it's possible that the UI is just not there. So once you remember the black box concept and what it implies, you will need to define what your black box should do. What do you want it to do? In the examples we're going to look at, we have several classes that are doing different things. The main one being a form management, so you need some function to do what you need. Initialization, save, and so on and so forth. So that is going to give you your methods, the procedure that you will have in your class. Then you also need to define what the black box is going to need to do what you want it to do. It's going to need some information, it's going to need some parameter value, that's the parameter of your method, that may be just the parameter of the init method or the parameter of anything else, but it's going to need some information, so that gives you the parameters. And also that will tell you what members, what variables you're going to need inside your class, because that's the value that you need to store and be able to get from one call to the next on the same object. You also need to define what results do you want out of your class. These results are going to be the value that are returned by each method. So very often the only thing that you need out of the class is, did it work or not? So you will have a result that is just true or false. Okay, work was done. And if you get a false result, then you ask the other method, get last error, and depending of the code of the error, of what this or that, you do whatever you want in your class, in your outside your class, in the code that is calling your class. So also in some cases the results are going to be very important calculation results and all that. So you will need to define exactly what result you want, and that's the value that are going to be returned by each method. Well, as you can see, it's not that different from regular programming. It's just that you have this black box concept that is extremely interesting, and that you need entry point, exit value, information stored, and functions. So that's just what you would do normally. It's just a little more formalized and a little more organized. And the very, very, very important thing in object-oriented programming, in a successful object-oriented programming, is that you have to design your class as completely isolated from the project in general. You have to be able to get your class in another project and just use it. If when you put it in another project you have compilation error because, well, you're using global variable, a global procedure, or element of the UI, then your class is badly designed. It's not doing what it's supposed to be doing.